Azure Storage offers flexible access tiers, hot, cool, and archive, to address different usage patterns and cost expectations. These tiers allow organizations to store data efficiently, aligning their storage strategies with performance and budget constraints. By using the hot tier, frequently accessed data remains readily available, ensuring swift read and write times. Conversely, infrequently accessed data can be moved to the cool tier, lowering storage costs but slightly reducing access speed. Finally, the archive tier is designed for rarely referenced data, providing the greatest cost savings at the expense of near-immediate retrieval. Understanding these tiers is crucial for optimizing resource allocation, especially in large-scale implementations, such as archival of compliance records or rarely accessed backups. Each tier can be set at the account or blob level, allowing granular control over where and how data resides. This segmentation also permits organizations to adopt best practices in lifecycle management, automatically moving data between tiers based on usage patterns. The hot access tier in Azure Storage is optimized for mission-critical data and workloads requiring frequent read and write operations. This tier supports low latency and high throughput scenarios, such as hosting analytics data or frequently updated documents. While the hot tier typically incurs higher storage costs, its performance-oriented design helps ensure minimal delays for users and applications that depend on real-time interaction. By storing actively used content, like web assets or transaction logs, within the hot tier, organizations can maintain efficient data processing workflows. Additionally, this tier is well-suited for DevOps processes that continually revise and redeploy resources. Administrators should weigh the trade-off between performance necessities and pricing structures, bearing in mind that data kept in the hot tier can generate substantial costs if large volumes of information are left over time without usage optimization. Monitoring access frequency and resource requirements is advisable to ensure that the hot tier remains cost-effective in the long term. The cool access tier in Azure Storage caters to data accessed less frequently, but which remains important enough to retrieve within a shorter time frame than is typically allowed by the archive tier. This tier offers reduced storage costs compared to the hot tier, though slightly higher access and retrieval fees may be incurred when reading data. Use cases often include backups, logs, and organizational data that need retention for regulatory compliance, but do not require instant interaction. Cool tier is also suitable for data that may only be consulted sporadically, such as historical performance metrics or large media files that no longer drive everyday operations. Though the read operations are subject to greater latency, the cool tier provides adequate responsiveness for occasional accesses. Strategically transitioning data from hot to cool when usage patterns diminish can yield substantial cost savings. However, administrators must ensure that retrieval times remain compatible with operational demands and service-level agreements. The archive access tier is designed for data rarely accessed, yet still necessary for organizational or regulatory purposes. Compared to the hot and cool tiers, the archive tier significantly reduces storage costs, making it ideal for long-term retention of historical data, financial records, or seldom referenced backups. However, this tier requires a rehydration process before data can be read or modified, leading to potentially extended retrieval times, ranging from several hours to days, depending on the volume and priority. This latency trade-off is acceptable for data that must be preserved but is unlikely to be accessed under routine circumstances. Organizations should plan carefully when moving critical content to the archive tier, ensuring that emergencies or audits are addressed beforehand. The archive tier's cost-effectiveness can dramatically reduce total storage spend, but administrators must be mindful of associated overhead for rehydration requests and the potential complexities in bringing data back into a more accessible tier. Azure storage tiers can be configured directly in the Azure portal, providing an intuitive interface for administrators. By navigating to a specific storage account, one can configure the default access tier and subsequently modify tier assignments at the container or blob level. Granular adjustments allow finely tuned resource utilization, enabling cost optimization strategies without impacting overall operations. To change the tier of existing data, an administrator can navigate to a blob settings, select the desired tier, hot, cool, or archive, and confirm change. The interface also offers insights into anticipated costs and performance implications, guiding informed decision-making. Additionally, the portal's built-in monitoring tools can reveal data access patterns to help refine tier allocations. This visual approach offers simplicity, facilitating quick adjustments when usage patterns shift unexpectedly. Though portal-based configuration is straightforward, administrators who manage large data volumes often prefer automated processes and scripts to standardize the tiering strategy. In addition to the Azure portal, administrators can configure storage tiers using Azure CLI or PowerShell, offering a more automated approach for large-scale or repetitive tasks. For instance, with Azure CLI, commands like AZ storage blob set tier enable granular control over tier assignments, allowing bulk operations. This method is especially useful for scripting complex workflows, integrating tier changes in a CI/CD pipelines, or applying uniform policies across multiple storage accounts. PowerShell provides similar capabilities through the set as a storage blob, contlet, supporting programmatic tier changes and conditions that trigger transitions. Administrators can leverage these tools to streamline data governance, ensuring that rarely accessed files automatically move to the cool or archive tiers after preset retention periods. By constructing scheduled scripts, organizations reduce manual labor while maintaining an adaptive storage environment. This approach also eases the burden of monitoring usage patterns, because repeated commands can be executed as needed, aligning tier configurations with real-world business cycles. Azure Lifecycle Management policies enable administrators to automate the movement of blobs among tiers based on rules related to last modified dates, access frequencies, or custom triggers. These policies help maintain an efficient storage environment by regularly reassessing data usage and moving items to more appropriate tiers without requiring continuous manual intervention. Rules can specify, for example, that data not accessed for 30 days in the hot tier be transitioned to the cool tier and subsequently moved to the archive tier after 180 days of inactivity. Such automated workflows support cost optimization, prevent storage sprawl, and establish consistent governance practices across multiple workloads. In addition, lifecycle policies can delete data that no longer holds business or regulatory value. Administrators should design these policies with the organization's compliance, retention, and recovery objectives in mind. Properly configured policies reduce errors and free staff to focus on higher-value tasks while ensuring data is stored in the correct tier. Consistent monitoring of storage tier costs is crucial for organizations aiming to balance performance requirements with budgetary goals. Azure provides built-in metrics and cost analysis tools that offer insights into storage consumption, including detailed breakdowns by tier. Administrators can visualize data usage patterns, identifying which blobs experience frequent access and which remain dormant. With this information, cost-effective tier adjustments become more precise. For instance, if metrics reveal a surge in read requests against a blob in the cool tier, it may be more economical to return it to hot. Conversely, if certain data remains untouched for months, a transition to the cool or archive tier could bring substantial savings. Cost monitoring is further refined by tagging resources, enabling departmental chargebacks or cost accountability across multiple teams. By continuously evaluating telemetry and usage analytics, administrators ensure that each dataset resides in the most appropriate tier, aligning with performance expectations and financial constraints. In Azure, moving data between tiers is a straightforward yet critical step in any robust storage strategy. Tier changes at the blob level allow administrators to adapt storage settings when usage patterns evolve. While transitioning data from hot to cool is immediate, migrating to or from the archive tier requires a rehydration or archival process. These workflows can involve significant lag times, so planning is key, particularly when migrating large volumes of data. Policymakers should also note that tier changes can incur transaction costs, making it prudent to batch updates or schedule them during periods of lower network demand. The ability to seamlessly shift data paves the way for effective lifecycle management, especially when integrated with monitoring and alerting systems that notify administrators of usage anomalies. By combining short-term operational data in the hot tier with historical data in the archive tier, organizations can orchestrate cost-efficient storage that scales with their evolving data requirements. Certain use cases demand nuanced tiering strategies. For example, data analytics pipelines may require historical data to be periodically referenced. Staging data in the cool tier can provide the balance of lower storage costs and acceptable retrieval times. When older datasets need to be reprocessed for trend analysis, administrators can schedule rehydration from archive well in advance to avoid delays. Similarly, big data solutions that house significant volumes of curated information may shift from hot to archive quickly, as soon as ingestion completes and the data is no longer in active use. Integration with advanced tools, such as Azure Data Factory, can further automate this process, dynamically moving data across tiers as new analytics tasks arise. Another scenario is enabling multi-tier replication across different regions, ensuring data redundancy in both cool and archive. Advanced tiering strategies thus provide resiliency while optimizing overall spend, particularly for large-scale applications where data patterns are inconsistent. Organizations that handle large amounts of multimedia content, such as marketing collateral or production footage, frequently benefit from tiered storage. Hot tier storage accommodates files needing quick responses, while older videos or images can be moved to cool or archive as they become less relevant. In the financial sector, regulatory documents that must remain accessible for audits yet are rarely accessed can be strategically placed in the archive tier to drastically cut storage fees. Software development teams often keep build artifacts in a cool tier, readily available for troubleshooting or rollback events. Similarly, companies maintaining IoT data might triage event logs in cool before archiving them to reduce operational overhead. In many scenarios, Azure functionality, like Azure Files or Azure Data Lake Storage, blends seamlessly with tiered storage to create cohesive data solutions. By mapping use cases to tier availability, organizations find a balanced approach that satisfies both performance needs and prudent expenditure of resources. Automation underpins many tiering strategies in Azure, ensuring consistent policies across sprawling data estates. Administrators often integrate Azure policy to enforce tier-related rules, such as default placements for all new blobs or mandatory lifecycle transitions after a defined period. This helps maintain compliance while reducing variance in data handling. Additionally, governance frameworks can incorporate scripting and continuous integration, ensuring tier assignments align with project phases and data usage trends. Combining policy-driven deployments with role-based access control, RBAC, ensures that only authorized personnel can modify tier configurations. Furthermore, event-based triggers, fired by changes in data usage or metadata, can dynamically execute Azure functions that move data to more cost-effective tiers. This ecosystem of automation reduces manual labor, mitigates errors, and fosters consistent best practices throughout the organization. By thoroughly planning governance frameworks and leveraging automation tools, enterprises can expand storage tiering solutions in a structured, efficient manner. While cost savings drive many tiering decisions, performance metrics should factor heavily into tier selection. The hot tier offers the fastest access times and is well suited for data-intensive workloads or critical transactional systems. Conversely, the cool tier may see slightly increased latency, which can affect operations dependent on continuous, low-latency reads and writes. The archive tier, with its lengthy rehydration requirements, is impractical for applications needing immediate access. Maintaining performance also depends on how frequently data transitions among tiers, as repeated migrations can introduce overhead. To balance cost and responsiveness, some organizations implement a multi-tier approach with frequently used data in the hot tier, moderately accessed backups in the cool tier, and rarely used archives in the archive tier. Integrating real-time monitoring to identify bottlenecks ensures that performance impacts are quickly recognized, prompting a reevaluation of tier assignments. Maintaining an agile, data-driven process helps administrators deliver balanced, efficient solutions. Security considerations remain paramount, regardless of the chosen tier. All tiers, hot, cool, and archive, allow integration with Azure storage encryption and identity-based access controls, aligning with principles of least privilege. When shifting data between tiers, administrators must uphold consistent policies, such as requiring secure transfer, HTTPS, to prevent interception. As data moves to the archive tier, encryption at rest remains active, ensuring confidentiality of rarely accessed records. Integration with Azure Key Vault can offer additional control by managing encryption keys and rotation schedules. Features like stored access policies and shared access signatures, SAS, can be tailored to specific tiers, limiting how and when particular data can be read or modified. Administrators should also periodically audit access logs to confirm that data movements align with compliance requirements. By maintaining uniform security measures across all tiers, organizations reduce vulnerabilities, protect sensitive data through its entire lifecycle, and ensure that tiering strategies align with broader governance and risk strategies.